Hello everyone and welcome to Jam Academy. Now this is a continuation of the previous problem. Now in this case we have the same car of 2300 kilograms ascending a hill, a 10% grade hill. What does that mean? It means that the hill is rising 10 meters vertically when it moves 100 meters horizontally. It will help us to calculate the angle or the inclination of the hill. I love this problem. You often, if you're driving maybe from Los Angeles back to Fresno, California, you will descend a hill which is about 6% grade hill and is pretty much very steep. So what does that mean? So the question is, what power is required to calculate what power is required to drive the car up and down a 10% grade hill at a speed of 75 kilometers per hour. Now, keep in mind, don't make no mistake, when the car is ascending the hill, the work done by gravity is negative. But when the car is descending the hill, the work done by gravity is positive. So think about it. Why is that the case? In order for you to see the implication of my statement, let's begin first by drawing a free body diagram. We are going to do two free body diagrams. One that involves the situation in which the car is going uphill, and the other that involves a situation in which the car is going downhill. So let's roll. We have here the weight of the car obviously acts vertically downwards. This is mg. The normal force on the car acts perpendicular to the surface. Now you have the traction force. This is F. Now there's a resistive force backwards, but we are going to assume that there is no resistive force in this case. Now, the weight of the car can be resolved into two components. You have, this is mg cosine theta. This is mg sine theta. Remember, the car is going uphill, which means that the displacement of the car, so the car is going uphill, which implies that the displacement of the car is in the opposite direction to the direction in which gravity acts. The component of gravity, this particular component, mg sine theta, it acts in the opposite direction of motion. That explains why when the car is going uphill, the work done by gravity is negative. What does that mean? It means that the power required to drive the car uphill is equal to the power needed to drive the car on the horizontal surface plus the power required to overcome the force of gravity since you're driving uphill. That being said, the power required to overcome gravity is just equal to the force of gravity, which is opposing the car. In this case, this is mg sine theta multiplied by the speed of the car v. Now, this is going to be equal to 2300 kilograms. I'm going to just take g as 10, just to simplify the whole scenario. 10 meters per square seconds. Now the sine of theta, what is theta? Remember, if the car moves a distance of 100 meters horizontally, then the vertical distance climb will be 10 meters, which means that the tangent of theta, it's gonna be equal to 10 all divided by 100, which means that theta is equal to the tan inverse of so this is going to be sine 5.71 degrees. So let's calculate that. Multiply by 10, multiply by 2300. So we will have here 2,288.6 watts, 2,288.6 watts. But the thing that we have to do in this particular scenario is we have to convert the wattage into horsepower. So this will be equal to 2,288 watts, or multiply by 1 horsepower is equivalent to 746 watts. So if you divide that by 746 divided by 746, we will have 3.1 horsepower, 3.1 horsepower. So we need 3.1 horsepower in order to counteract the force of gravity opposing the car climbing uphill. So the total power required will be equal to 10 horsepower plus 3.1 horsepower, which is going to be equal to 13.1 horsepower. So this, my friends, will give us is the power requirement. Let me say that again, is the power requirement to drive the car uphill. Now, what about downhill? To drive the car downhill, the mathematics is going to be a little different because the car is moving downhill. Now, the diagram is just the same. The free body diagram is the same. The only difference in this case is that the object is moving downhill. And if the object is moving downhill, instead of gravity doing negative work, gravity will do positive work, which means that the power required to drive the car downhill is the power required to drive the car on a horizontal surface minus the power contribution from the force of gravity. In this particular case, P down will be equal to 10 horsepower minus 3.1 horsepower, which is going to be equal to 6.9 horsepower. So you require less power to drive the car downhill, which makes sense because gravity is doing positive work as compared to driving the car uphill. Thank you so much, fellas. If you have any question, please do not hesitate to ask in the discussion forum below. Remain blessed, and bye-bye.